In this video, we're going to use one-sided limits of a given value to determine the limit of our function at that given value. So in this case, how we're going to do that is we're going to analyze the limit from the left and from the right of our function that we have here, which is 3x over x squared minus 4. In the case where we have a function that's represented as a ratio or a fraction like this, the best course of action for us to take is to analyze both the numerator and denominator in the separate cases of approaching the given value that we have, which in this case is 2, from both the left and the right. However, we see that in both cases, our numerator approaches 6. Now, the reason for that is, let's look at as x approaches 2 from the left. As we get larger and larger numbers, as we get closer and closer to 2 from the left, we see that the product of 3 times that number that we use is going to get closer and closer to 6. And it's similar for the case as x approaches 2 from the right. We're going to be using numbers that get smaller and smaller while getting closer to 2, and we see that that product is going to become closer and closer to 6. So in both cases, our numerator approaches a positive 6 in this case. So that's good to keep in mind. Now let's look at what happens in the denominators. So as x approaches 2 from the left, right there, we see as we get closer and closer to 2 from the left, the difference that we have in our denominator is going to remain negative. It's going to grow smaller and smaller in terms of negative numbers, but it's still going to remain negative all the way up until it hits right before 2 coming from the left. So let's go ahead and write that down. So we have the difference in denominator, go and abbreviate there, is less than 0, meaning our ratio is approaching negative 6 over 0, meaning our limit as x approaches 2 from the left of our function is negative infinity. Okay, so we've looked at what happens to our denominator as x approaches 2 from the left. Let's look what happens to our denominator as x approaches 2 from the right. We see that any number greater than 2, which is what we're going to get as we approach 2 from the right, is going to result in a difference in our denominator being a positive number. So we get that the difference in denom, again here we're going to kind of abbreviate, is going to be greater than 0, meaning our ratio is approaching (6 over 0), or that our limit as x approaches 2 from the right is positive infinity. So when we analyze the behavior of a function to find its limit by using one-sided limits coming from the left and the right of a given value, we want to see if our one-sided limits agree. And in this case, we get the case where they do not agree. So that means that the limit as x approaches 2 of our function, we'll go ahead and write that down, limit x approaches 2 of 3x over x squared minus 4 does not exist.